I've always taught in my classes that we solve all the problems in terms of the tools that we have available. So when you're in the first programming class, you have this set of tools available to you, and you got to conceive of your solution to all the problems with the stuff that you have. So, and Magic the Gathering would be the same. It's just less convenient. I stopped playing Magic way before they had the online version, but the online version's still not that great. So you basically had to find somebody to go and sit down with and actually play with physical cards, and that's just not convenient. So, I mean, I guess I don't know if I have a strong feeling about which is better between Magic the Gathering and Hearthstone. I suppose maybe Magic requires more true skill, where Hearthstone has more luck built in just because of the nature of some of the cards, because it's only digital. But at the very least, being able to find real human opponents, just by clicking a button, I have found to be pretty interesting. So yeah, I don't know. I'm just hooked on the game, and I'm looking for other people who play that, we can like jump on Zoom or something and actually, talk trash. Because I hate on Hearthstone or Hearthstone, however you say it, that you only have like 5 things you can say. You can like say hello or well played. And say, I want to do some smack talking. All right. So let's see. This class is what? Systems programming. So let me. All right, everybody can see the presentation thingy.
Yep.
Oh, and it looks like I uploaded your syllabus to the 300 class. So I'll fix that right after class is done today, but we'll talk about all this stuff. Let's see what we're doing here. All right, so first of all, especially since we have, let's see, I think everybody else in here knows each other. But Hunter, you want to introduce yourself? All these other people are Concordia Mequon folks.
Yeah, I can introduce myself. I'm Hunter Smith. I go to Concordia Ann Arbor. I'm on the football team and esports team here. And I mean, I grew up in Michigan, really. I was a little confused today when I got on at 1:10 and was in the waiting room and was like, oh, this is weird. I forgot about the time change.
Oh, right.
Yeah.
Yeah, it's 1:17 here.
Yeah.
So what's your game of choice for esports?
I'm on the Smash Bros team.
Smash Brothers. Anybody else in here play Smash Brothers?
I do.
That was Sam?
Yeah.
Yes, sir.
Is anybody else in here on esports in Mequon?
Nope, I'm not on the esports team.
Okay, well, so let's see. Everybody else, does everybody else in here know everybody?
Yeah, I believe so.
Because I mean,
Yeah, I'm pretty sure.
yeah. So Hunter Brocker is he's pretty bright. Jarrett is like not a real person. Sam's a good guy. Jacob's a good guy. Noah's garbage. You don't want to talk to Noah.
Agreed.
All right. So so first of all, grading. I'm going to do the Bible homework a little bit different this semester. In the past, I've done like, the one assignment per week that, needed to be done by midnight on Sunday. And I don't know, that I kind of enjoyed grading them, but at the same time, it was a lot. So what I'm going to do is there's going to be 3 Bible homeworks. Each one is going to be to read, several chapters or something like that, or a short book in the Bible, and then write like a 1-page paper kind of response. And I'll make all 3 of them due by the end of finals week. So you can pick and choose when you want to spend the time doing it. My encouragement to you would be to set up a weekly reading that divides the 3 assignments up so that you get into the habit of, reading the Bible once a week or twice a week or however you want to do it. That's kind of the mentality behind the assignments, is I'm kind of forcing you to read the Bible, and I'm cheating off of God by throwing the Bible in front of you and basically saying, hey, well, you're going to read it and then God will take care of the rest. So, if you have a different religion or not into religion, that's fine. Concordia is a Christian school, so deal with it. So at the very least, you're learning about the beliefs of your classmates, some of your classmates, your teachers, things like that. But worst case, my feeling is I want to get you into a habit of spending some time with God on a weekly basis or something like that. So that would be my preference, is for you to, kind of break the assignments up so you're kind of working towards them before the end of the semester. But worst case, if you want to just knock them out at the beginning, you can. If you want to fill them in whenever you want, I'll just make them due by the end of the semester. So with that being said, your Bible homework is 10% of your grade. Your normal homework, most of which will be programming, but it's there'll be some papers and stuff too. That is going to be 50% of your grade. Midterm is 20%, final is 20%. And then my usual policy, if you do better on the final than you did on the midterm, I will replace the midterm exam score with the final exam score. All right, so also for homework, let's just create another slide for this. So academic dishonesty thing. So first of all, the warning would be for for any of your classes, make sure you understand the teacher's policy regarding collaboration and stuff like that, so you don't run into issues with academic dishonesty. For those of you who've had me before, I'm pretty easygoing with this. I encourage to work in groups on the homework, as homework is practice for the big game, and I will find out on the exams if you have learned anything. Okay, so basically homework assignments, I grade them fairly easily. Every single time you do a homework assignment, there is a self-assessment, which most of you have dealt with before, but it's on Blackboard. It'll be over on the left-hand side, that you should include with the homework assignment, telling me what went wrong, what went right. Programming specifically, sometimes you might spend hours on something and have very little to show for it in the end. So with that in mind, always turn in that self-assessment so I can get a feel for your effort you put into this and where you went wrong, what you tried, what didn't work, stuff like that. And that can zero me in on, where your bugs are, so I can give you some feedback, or give me an idea on partial credit in the event that you put in a lot of effort and, didn't have much to show for it. Again, I'm going to find out on the exams whether or not you've learned anything. That's the purpose of those assignments. So, there doesn't, basically work in study groups, set something up on Zoom, whatever it is, work on homework together, bump ideas off each other, post stuff on Slack, asking questions, whatever you need to do to learn the material, because that's the ultimate goal, is to learn the stuff at the end of the semester. All right, questions about that? Okay, then let's go. It's not Ubuntu, it's Ubuntu, right? Like that. You spell it. Ubuntu, yeah. All right, so you are encouraged to get an Ubuntu Linux distribution installed on your computer. So a couple of options here. One option is to use VirtualBox from Oracle to install this. That will use some of your system resources on your computer to run it at the same time. So for instance, right here, I'm using Parallels, which is like a paid competitor to VirtualBox. And I'm running Ubuntu on my computer, and it's using some of my computer's memory and processing power and stuff, some of the stuff like that. So that's one thing you could do. You could dual boot it on your machine. So you have to restart to get to the Ubuntu environment. If you live on campus now, so this won't help you, Hunter, but if you live on campus here, we have a couple of new environments set up. So near the CS department is a Wi-Fi called CUWCS. Password is that. Very secure. And what that'll do is that will get you access to a new wireless network that is specifically for computer science. Now, this network is not necessarily the preferred network for you to join when you are on campus. It's only available near computer science, and it is gives you access to a segregated network on campus that is behind a firewall, and you have access to stuff that we are now providing. Now, you'll have internet connectivity, but you won't be able to reach. I think from a student's perspective, you probably can do most of the things that you can do on like FalconNet and stuff like that, but you probably cannot reach SharePoint drives if you are in any clubs or something that have access to any of that stuff. So it is a different network than FalconNet. Physically, it's segregated so that we can do some stuff. So near the CS department, there's a Wi-Fi network called CUWCS. And on this network, we have a VM server where you can host your own Ubuntu virtual machine. And whenever you need to work on your homework, you can come to class, come to the department and use the VM from your laptop or one of our Macs. Now, realistically, this is kind of a note, let's say, you can install, I like VNC Server on your VM and potentially reach it from off campus / in your dorm room on a different network. One possibility though is that our it's called vCenter that we use might put your VM to sleep if the resources are needed for another VM. So if your virtual machine is currently running with your VNC server on it, and you're not actually currently using it, vCenter makes some decisions on what should go to sleep and what shouldn't go to sleep. So it's possible that you won't be able to reach your virtual machine from your dorm room, for example, after you've originally set it up in the department. Because it's gone to sleep and it's no longer talking to the vCenter or no longer talking to VMware server. All right, or VNC server, sorry, VNC server. So the way VNC server works, so just to kind of draw you a picture of our new setup in the department, several of your other classes might be using this. So we have CUWCS network. Then we have FalconNet. And these guys are not related to each other. They both share the same internet backbone. So let's put this up here. This is our vCenter. Okay, so this is sitting behind a firewall. So if you're off campus, well, actually, really, if you're off CUWCS Wi-Fi, you won't be able to reach the CUWCS network. The mechanism to reach this is through physical ports inside of computer science or CUWCS Wi-Fi. Okay, that's the mechanism to reach this network. Now, the way that, if you've used TeamViewer before, it works the same way as VNC Server, but in the cloud, real VNC cloud allows a client computer,
This screen that you're sharing is frozen
is it?
for at least a couple of us. Like I just see the Falconet and CWCS network blocks.
Yeah.
Is that for everybody? Let's try this again.
That's all I see currently.
Ninja. How about now?
I can't see anything now.
Well, that seems good.
It says that you started screen sharing.
And what, it's just delaying? All right, stop screen sharing. Let me try just sharing Keynote.
Nothing yet.
I think this is Clancy's fault.
It has to be, right? Who are we gonna blame in this class?
Where is Clancy? Isn't he in this class?
No idea.
No, he's already at like 18 credits or something this semester.
Let's see, what can I do?
There we go.
We're back.
All right, so you can see it now?
Yes, sir.
All right. So here's your VM. And we'll put this guy over here. So even though your VM lives inside, well, actually it's the vCenter is here. Your VM lives inside the vCenter. So from on campus, your way of getting to your virtual machine is through the CUWCS Wi-Fi. But now if you have VNC Server running on your virtual machine, what it will do, oh, I need to hide this. Is it will register itself with real VNC Cloud, which will then allow you to use VNC client, from off campus or anything off of CUWCS Wi-Fi, you'll be able to access your virtual machine through Real VNC's cloud. And this is free. So when you do Real VNC, you can set up an account and it'll allow you to use up to 5 computers in this way. The reason why this isn't guaranteed to always work is your VM here might get put to sleep by vCenter. So if it gets put to sleep by vCenter, this connection will no longer exist. So you won't be able to get to it. So that'll be something you have to experiment with to see if it stays alive or whatever. But if you wanted to host your Ubuntu Linux install on our virtual server, that's what you can do. So you have multiple options here. At the end of the day, we're going to be running Linux, and I'm going to specifically be doing examples with Ubuntu Linux. So I would suggest you run that so that you are working with the same Linux kernel code as I am, in case there's a weird change in one Linux distribution versus another for something stupid. They should all be the same, so it shouldn't make a difference. But if you just want to keep things as compatible as possible, Ubuntu Linux is free. Go and download it, put it on your computer as a virtual machine, as a, you could do it as a live boot off of a USB stick, although that runs pretty slow, so I probably wouldn't do that. But run it as a virtual machine, dual boot it on your computer. If you have another computer you want to just install it on, do that. Otherwise, you could run it on our virtual machine server here on campus, and then you don't have to use any of your computing resources to drive it, but you might need to be near the department in order to use it. All right, so questions about your various, and then you can go and watch YouTube videos or whatever on how to get Ubuntu installed or follow a tutorial. It's no more difficult than, it's probably actually easier than installing Windows or something. Just you download it, you start the installer, and it just goes from there. You will probably use a tool like Etch or something to burn a USB stick with the installer and then just boot off of that. But it'll be a good exercise. Follow some YouTube video on installing Ubuntu on your computer. It's not something we're going to do in class. As far as using it on our virtual machine, what I'll do is I will have Ubuntu already installed on vCenter. And then what you'll do is you'll spawn a duplicate of that. And I'll do a tutorial of that in class one of these days. You'll spawn a duplicate of that with your name on it, and that will just be your virtual machine. So you won't actually have to install Ubuntu if you're using our vCenter. We have the ability to just spin up multiple copies of a running operating system, but you'll want to put your name on this one. That way it's your computer, so things that you leave behind will stay there and other people won't be messing with it. You'll set up your own user account on there so the data is protected. All right, questions about the Ubuntu thing. One way or another, get Linux on a computer you have access to is the punchline. Okay, so that in mind, what is systems programming? What does that mean? What does systems programming mean to you? Well, somebody should start off by making something up so I can tell you you're wrong, and then we'll go from there.
I would say programming like an operating system or a kernel.
Okay, well, so that's not as wrong as it could have been. So maybe programming related to an OS. Now you said kernel. What is a kernel?
What people think an OS really is. It's the background of happens.
So at the end of the day, here, I'll just put this on its own slide. The kernel. This is the actual OS, i.e. Linux kernel. What other kernels do you know about?
Windows kernel.
What's that one called? It's not called the Windows kernel.
I'm drawing a blank on it right now.
NT kernel. So that's new technology kernel. There was a 9X kernel. That was the kernel that was used up through Windows Millennium, Windows ME. Actually, I mean, I think I've probably done this in a class that you've had with me before, but it's an interesting little thing that we can do. Windows OSs. So first of all, when I say what operating systems have you used, this previous slide here kind of talks about the mistake a lot of people make, and Noah mentioned it. It's what the actual operating system is, or what people think the operating system is. Windows 95 is not an operating system. What is Windows 95 or Windows XP or Windows 10? What if that's not an operating system? What is it?
Then it's just a front end GUI that you use on top of a kernel.
Okay, so a lot of times these things would be called distributions, right? Windows 10 is a distribution of the NT kernel, and distributions come with the core operating system, which is the NT kernel, and all the things that are common to that operating system, with a bunch of stuff on top of it. So one thing you mentioned is the GUI, but it also has a whole bunch of software applications installed, right? You know, you can expect you have Notepad and probably a web browser installed, and you know, a bunch of maybe a paint program or a PDF viewer, things like that. There are common pieces of software that are presumed to be, let's say, roughly required for being productive on an operating system fairly quickly. And those would be things included inside of a distribution of an operating system. So Windows 10 is a distribution. So if we go back to Windows OSs, let's actually just call this Windows distributions. Actually, let's call it OSs and distributions, because it's going to be related here. And I'm actually going to create 2 of these things. All right, so what's the oldest version? And actually, I'm going to, let me do this. Range. Well, that part doesn't matter. So we're going to call these consumer and business. So what is the oldest Microsoft-based operating system or distribution that you are aware of? I'm guessing that everybody's mic is muted because you should all be talking because you're aware of something.
Wouldn't it just be like Windows 1?
Okay, well, are you aware of Windows 1, or are you just guessing that that must have existed?
Did a quick Google search.
All right, here, I'll start you off. How about DOS?
I was going to say DOS.
All right, so DOS, disk operating system. What came after DOS? Let's just hit the popular highlights. So maybe Windows 3.1. That was kind of the first cool kid.
Is Vista one?
Windows Vista was definitely one-ish.
Is XP another one?
Yep, Windows XP. What came before Windows XP? I already mentioned it once in here. Windows 95, Windows 98.
There was a Windows 2003, wasn't there?
Okay, so I'm glad that you're starting to bring those up. I'm going to finish this over here. So I'm going to say Windows 10. Actually, there was Windows 7, then Windows 10, right? That gets us current over here. These are the consumer operating systems. And this is related to systems programming, and I'm going to give you the relation here in a minute. Now, actually, hold on. I want to steal these. That'll work. So we had DOS, we had Windows 3.1, and then we had something called Windows NT 3.51. And then we had Windows NT 4. And we had Windows 2000. Now, this is where things get kind of interesting. If you were a consumer, this is in kind of the early days of consumer PCs where they had already become popular. So Windows 3.1 was pretty early on in the PC craze where people didn't necessarily, we didn't know for sure it was going to catch on. But Windows 95, I mean, at this point, people were running Windows. Right? People were running PCs at home, okay? A large percentage of people. But while Windows 3.1 was out, this guy ran on top of DOS. So his kernel was the DOS operating system. So this was the operating system. This distribution was a GUI and other pieces of software that ran on top of DOS to make life easier. Windows 95 still ran on top of DOS, but I'm going to go ahead and change this to 9X kernel because it started being kind of called interchangeably at that point. And at one point, they just renamed it to the 9X kernel and emulated old DOS because they kept upgrading DOS. Windows 98 was DOS/9X kernel. Now, something that's interesting that happened here, though, is if you are a consumer back then, I mean, one of the things I like to focus on with computer science students is that you should be the technology experts. You shouldn't be able to get to walk into Best Buy and get taken advantage of. All right. You know, I've made fun of students in past classes. You know, if you didn't know what the speed of your internet connection at home was. Now, I assume everybody in here knows that? Who has internet at home? All of you, right? What kind of connection? Is it DSL or is it cable? And what's the speed? Put it in chat. So for everybody, I want to know in chat what kind of internet you have at home, DSL or cable, and what the speed of it is. As technology students, you should all know that information about your network bandwidth and things like that. You are technology experts. Let's see, did I get any answers? Chat. All right. 100 megabits per second for Hunter cable, good. Jester just said yes. Oh, that was for the shared screen thing. That's pretty funny though. Yeah, I got internet. Yeah, see, now I feel like, well, definitely Jarrett just cheated off the previous people. All right, so yeah, so I mean, if you have internet at home, cable modem, most of the time they start at 200 megabits per second now, in the bigger cities at least. And then, you know, usually have like a 400 or 500 megabit per second that's considered fast, like ultra fast. And then now they're starting to have like gigabit internet in some areas. Not going to get too far into that. Andrew, you do not have DSL at 200 megabytes per second for sure. You also don't have it at 200 megabits per second. Fastest DSL you would have is probably 24 megabits per second.
My bad.
Yeah, so you get to go figure out what that is. If it's 200 megabits per second, then it's not DSL, it's cable. AT&T and Verizon both have fiber-based technologies that can go up that higher speeds like cable, but DSL is a pretty old technology that requires you to be close to the what's called the DSLAM, effectively the telephone company or one of their pieces of equipment they put into a neighborhood, because your speed is relative to how far you are from that. But DSL is nice because it runs off of POTS network, which is plain old telephone service. So your normal telephone lines, those copper cables, deliver DSL to houses using those as a network transmission. So it's not like it's garbage. In fact, it's pretty consistent, but you do lack the maximum speeds. Noah's like, it's like, well, the source is 100 megabit per second cable, but I steal it from my neighbor, so it usually doesn't perform that well. All right. So in any case, just as an example, those are things that you guys should know about. Now, some of the things we're talking about right here is a little bit more of a historical concept. So if you didn't live through those times, I wouldn't necessarily expect that you know the stuff. But if you translate this into, if this was happening in the world today, as a technologist, these are things you should understand. So you want to know what the current state of technology is and stay up on that. So now if we go back into the day, if you had Windows 98 at home, and at that point, personal computers were popular, very popular. Okay, they really took off with Windows 95. If you had Windows 98 at home, and all of a sudden you went into Best Buy and you saw Windows 2000 on the shelf, you would think that was an upgrade, right? It was not. Windows 2000, while it did come out after Windows 98, it was not the upgrade to Windows 98, because Windows 2000 is one of their business operating systems. So this guy here ran on the NT kernel, which was new technology kernel that Microsoft wrote. All of these guys were based on top of DOS. Where did Microsoft get DOS? Did they write it? This is kind of one of the most famous, probably the most profitable deal in potentially history. All of you have heard of Bill Gates, Microsoft guy. Well, way back in the very beginning, early days of Microsoft, they went into this unknown company. You guys have probably never heard of them, IBM. So none of you have heard of IBM, right? Back then, IBM was the cool kid. IBM back then was kind of like Microsoft is today, or even Apple is today, where they're kind of like they are technology, that type of thing. As personal computers were becoming somewhat commonplace in people's homes, and people were buying them, especially for businesses and stuff, Microsoft had a meeting with IBM, and because IBM was getting ready to start making computers that would, consumer grade computers. Now, when I say a computer, when we say a computer, we typically say, or we're usually implying the whole thing, including the software that's running on it. But the actual computer itself is just the hardware under the hood, right? What's the purpose of an operating system? What job does an operating system, or what problem does an operating system solve?
The actual kernel or the distribution on top of it?
The answer should be the same. But the kernel is fine. Let's just go off of the operating system, the kernel. What problem is it actually solving?
It manages resources.
Okay. Well, what did we do before we had an operating system? So you go back to one of those old computers like EDVAC or UNIVAC that you maybe looked at in the 175 class or something, or the 150 class if you had that class. Those computers that took up like a whole gymnasium. They didn't have operating systems, or they had very trivial operating systems. So those computers you had to directly manipulate through like vacuum tubes, right? You turn bits manually on or off. So an operating system acts as an interface between the human being and the actual computer hardware, so that you don't need to have manual interactions with the hardware in order to accomplish things. Make sense? So these operating systems, so anyways, Microsoft was, as computers were starting to get somewhat commonplace, to the point that IBM was thinking, hey, we should make these because we're the computer people. We've been making them for business, mainframes and stuff for years, and now we should get into the consumer market as well. So Microsoft went in there and says, you know what, you need our operating system to run your computers. And IBM was kind of him-hawing around or whatever, and Microsoft said, you know what, you don't even have to buy our operating system from us. We want to license it to you on a per computer basis. So only if you sell one of your computers do you actually have to give us money for the operating system. We'll give you a license for an operating system to run, or for our operating system to run on your computers. And IBM, this is kind of a famous quote, I'm going to get at least pretty close, said, oh, that sounds great, no problem. The real money's in the hardware. So that was not a forward-thinking statement. Obviously, software has made zillions of dollars since then. I don't even think that's not a real number, but you know what I'm saying. A lot of money. It's made a lot of money. Now, the funny punchline to this, though, is what was the problem? So IBM agrees, but what was the problem Microsoft had? This is one of our famous technology stories from the history of computing. So I'm Bill Gates. I'm sitting in this meeting. I tell them, hey, you need our operating system to drive your hardware, and you don't even have to pay us for it. Only when you sell a computer will we sell you a license for that computer. No problem. They had this agreement. Microsoft looked pretty good. They walked out. They have one problem. They don't have an operating system. They didn't have the operating system that they just sold to, well, they just made a deal with IBM to put on people's computers on a per license agreement. So they had to go out and find an operating system. And that operating system ended up being DOS. So there was a person who had written an operating system as kind of like his hobby project or something like that. And Microsoft went in and bought it from him for something like $50,000, which obviously I think DOS made a little bit more than that over the years. But hey, if you're somebody who wrote this operating system for fun in grandma's basement and somebody offers you $50,000 in the early 80s, you probably say yes, is the punchline.
Didn't the guy work at a Radio Shack or something?
Well, it was kind of like a place, but prior to Radio Shack, it was like a mom and pop hardware component place. Yeah. Yeah. I mean, chances are there was maybe a 30% chance he didn't even have pants on when they walked into the store. I mean, I don't think this place was really frequented. This was just kind of a super geeky place. And this was just his pet project. So anyways, DOS was purchased by Microsoft. They made some updates on it over the years, but Windows NT, the kernel, NT kernel, is actually Microsoft's own operating system. This is the operating system that they wrote. All right, so notice over here on the consumer side, early computers were only command line interface, CLI, command line interface, no GUI for this. Windows 3.1 was on top of DOS, but Windows was really the GUI software, and then the distribution was the software that came with it. Windows 95 was still DOS-based. Windows 98 was still DOS-based. You also had a Windows ME. Now, if you had Windows 98, you walked into Best Buy and you saw Windows 2000 on the shelf, you reasonably so would have assumed, oh, that's an upgrade to what I have, right? It was not. These are all running the NT kernel. Now, the reality is that Windows 2000 was among the most popular Windows operating systems ever. Still is. You probably can still find places that are running Windows 2000 as their server. It's not that it was a bad operating system. It's that These consumer operating systems, they had all of the drivers written for them for graphics cards and joysticks and things like that. External devices that consumers were using that business people weren't necessarily using. None of those pieces of software existed on the NT kernel. So if you were upgrading Windows 98 to Windows 2000, all of a sudden all your video games wouldn't work because your graphics card that you maybe spent extra money on was only running in generic VGA mode, not in the higher resolution mode that it was capable of, because there was no software written for it. So I'm going to put a little note here to remind myself where to start off next time. Where am I at here? So we're going to start talking about drivers. Windows 98 versus 2000. That's where I'll pick up next time. All right, so we're going to finish talking about kind of this history of operating systems, but we're going to start zeroing in on the systems aspect of it. So one of the components of an operating system are software drivers, which is our way of telling an operating system how to interface with a piece of hardware. All right, so we'll get into more details with it as we get into this, but that's the direction we're heading right now. Is if you are NVIDIA and you have this latest, greatest $2,000 graphics card, how do you make that card behave as this, monster truck that it is, as opposed to a generic graphics card that just makes colors show up on the screen? You have to have some way of teaching an existing operating system how to correctly utilize that piece of hardware that didn't exist when that operating system was written. All right, questions, comments, concerns, bribes. All right, no homework for Wednesday. Wednesday's class is in person. So I think this class is small enough that if you want to come in person, you can just come in person. If you would prefer to be online, I will have the Zoom session open and I will record on Zoom and all that stuff, but I'll be in the classroom doing face-to-face for whoever wants to be there. So officially, you are encouraged to come to the face-to-face class, but if you're more comfortable online or that's your preference for whatever reason, feel free to do that. I'm not going to, I personally don't care one way or the other. All right, questions, comments, concerns, bribes.
What language are we going to be using for this class?
C. We're going to be using the C programming language in Ubuntu, writing systems programming stuff, for example, drivers.
Okay.
All right, I will see everybody on Wednesday. I'll get the video posted, I'll get the slides posted, and I'll get the Bible homework up, but that's not due to the end of the semester, but just so you can start thinking about it. And then I'll make sure I put the syllabus in the right course. But I'll see everybody on Wednesday. Take care.
Littman,
Yeah.
Dana sent an email about my graduation stuff. I don't think she necessarily knows what she's talking about. So can you take a look at it? She copied you on it.
Yeah, I'll look at it here and